Good morning. Today is lesson 10.1, which is graphing y equals ax squared plus c. This is very similar to an equation that I'm not quite sure if we've seen before, ax squared plus bx plus c. We can use this equation to help us graph a quadratic function. This curve is called a quadratic function, and the shape it creates is called a parabola. So this equation is a quadratic function, and when we graph it, we call it a parabola. So it says the most basic quadratic function in the family of quadratic functions is called the parent quadratic function, which is y equals x squared, which is shown down here. The lowest or highest point on the parabola is called the vertex. So this is the lowest point of this graph. So this is what we would call the lowest point, which is a minimum. If it was the highest point, meaning if we were to graph and it would be going down, that would be what we would call a maximum. So right here, this is the minimum, and it just happens to be the point 0, 0. Then over here, it says the line that passes through the vertex and divides the parabola into two symmetric parts is called the axis of symmetry. So this line that they have down the middle, we like to draw a dashed line to show that's where our graph would fold in half. For example, if we are 1 square away from the axis of symmetry here, we would be 1 square on the other side. This is where our graph or parabola would fold in half. It's symmetrical on both sides. So this one is when x is at 0, or which is really the y-axis, because here x is 1, 2, 3. At 0 is where the graph folds in half, which is also known as the y-axis. So in order to create this, we are going to use today, go back for a second, a table in order to graph them. And we're going to actually graph this function in a minute, but all we did to create this graph is use a table and plug some things in for x to find y. So here are some examples of parabolas in real life. We have our McDonald's arches. If you just look at one of them, our axis of symmetry would be right here, and that would fold in half. This one might not be perfect, but this is a valley. Pretty symmetrical. If you look at just half of this, our parabola, looking something like that, would be symmetrical or the same on both sides. This right here is the St. Louis Arch in St. Louis, Missouri. Our drinking fountain, when you push the drinking fountain, it creates a parabola, a curve that will fold in half. Here's another example of a roller coaster, which hopefully all of us will be on the June 1st for our field trip. And then this one's a little bit hard to see, but this is someone shooting a basketball and trying to get it into the hoop. So right at the top there is when we have the maximum point of our parabola. So these are all examples of parabolas in real life. We're going to graph first our parent function, y equals x squared. Now this is a function that we're going to compare every other function we graph to. So make sure you pay attention to this graph. So we're going to plug some numbers in for x to figure out how far up should we go on our y-axis. So I'm going to plug in the numbers -2, -1, 0, 1, and 2 so that we get a graph, or get our points that are in the middle of the graph. If we go too far to the right or too far to the left, our points might not be on this graph. So first, if I'm going to start in the middle, the ones I know, with 0. If I just have 0 squared, well, 0 squared is 0. Then I have 1 squared, and 1 squared is 1 times 1, which is 1. And then 2 squared, 2 times 2 is 4. We can do the same thing on the other side, but this is where you need to be careful, because this -1 is the whole x right there. So we really have -1 squared, or -1 times -1, which is +1. Same thing with -2. A -2 times a -2 makes a +4. So let's plot these points, 0, 0, 1, 1, 2, 4, and then same on the other side. Now, don't connect your dots and make a straight line. We want to make a nice curve. Eventually, our lines will be pointing almost straight upward or almost vertical. But do your best to form a nice curve, that parabola shape. This is a graph again that we're going to compare every other graph to. So some characteristics of this graph right away. I like to think of these arrows as like arms opening up. With your hand up here, these are your fingers. If this is you, here's your arms, this graph opens up. If the graph was opening down, your arms would be pointing down, but they're not. So this one we can say opens, opens up. Our axis of symmetry, where does our graph fold in half? We abbreviate this AOS, axis of symmetry. This axis of symmetry is right at our y-axis, or when x has reached 0. So our axis of symmetry is when x is 0, that vertical line right there. And then our vertex. This vertex of this blue graph is the lowest point. We can ignore my stick person that I drew. The lowest point in this graph is this blue point right here. Our vertex, it's the lowest point, that's a minimum, and it is the point 0, 0. It's the origin. Let's take a look at our next slide. We're going to graph this same parent function, but now we're going to compare it to this graph up here, y equals 3x squared. So the only difference is this one will be 1x squared and this one is 3. So let's see the difference between these two graphs. I'm going to start with this one down here, -2, -1, 0, 1, and 2. Because we already graphed this, you guys, we can copy our equation or our points from this previous slide. We have 4, 1, 0, 1, 4. 4, 1, 0, 1, 4. If you wanted to plug them in again, it should be just fine. Plugging in 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, and so on. I'm going to graph that one right away. 0, 0, 1, 1, 2, 4. There's my parent function. If you want to label that with x squared so we know which graph it is, you can. We're going to do the same thing over here with the same numbers. The only thing you need to be careful of when we are plugging this into this equation is that we're following the order of operations. So if we plug in a 0, we have 0 squared because we have to do our exponent first, which is 0, times 3, which is still 0. Then if I plug in a 1, you cannot do your multiplication first. You have to do your exponent first. So 1 squared is 1. 1 times 3 is 3. And then a 2. 2 squared is 4. 4 times 3 is 12. And the same thing on the other side. If we had a -1, -1 squared is still 1. And 1 times 3 is 3. Same thing with -2. A -2 squared, exponents first, makes a +4. 4 times 3 is again 12. So let's plot these points. 0, 0, 1 up 3, and then 2 up 12. 12 isn't going to fit, so we're just not going to plot those ones. But again, draw a nice curve, not just a straight line. So this one is 3x squared. So if you again think of these as people, here's my person. My arms originally were the blue graph. They were pointing pretty far up. But then we do what's called a vertical stretch. We stretched our arms way up higher towards the sky, up and straight up. All we did was take our equation and multiplied it by 3. So every point is multiplied by 3. Instead of 1, we have a 3. Instead of 4, we have a 12. So we did a vertical stretch by a factor of 3. Everything went tall and skinny. Then other things we need to compare. Which way does this graph open? Talking about this red graph, we're comparing it to the blue one. The red one opens up. Our axis of symmetry on our x-axis, when x is at 0, our graph folds in half right in the middle. I'm going to tell you today, every graph we do is going to have an axis of symmetry of 0 today. It will not next time. And then our vertex. Our vertex is the point. Oops, we're looking at the red graph. Still is at the point 0, 0. And that point 0, 0 is the lowest point on this red graph, so that's what we call a minimum. So we're getting the hang of graphing using a table in our quadratic function. Let's try a couple more. Oh, I'm going to go back for a second. I kind of skipped over the directions. It said y equals ax squared, where a, our absolute value of a, is greater than 1. If the number out front, ax squared, if a is greater than 1, it is always going to be a stretch, where our graph is going to be tall and skinny. Now, when a is less than 1, so here, not the negative, you could take the absolute value and it would be a positive 1/4. The negative is going to do something different to our graph. So the number is what we're looking at. A is 1/4, so if that's less than 1, this is what's going to be called a shrink. If that number is less than 1, it's going to be a shrink, meaning instead of our graph being tall and skinny, it's going to be maybe like shorter and fatter out this way. Call it a shrink. It fell down. Our arms are shrinking, falling down to the ground. So let's graph this one and see what it looks like. I did not give you a spot to graph y equals x squared. However, we still need to compare to that graph. So if we want to graph this one super quick, if we plug in a 0, 0 squared is 0. I'll plug in a 1, 1 squared is 1. If I plug in a 2, 2 squared is 4. Same on the other side. So we just graphed that super quick without even using a table. Next, let's plug in what we know about this equation. We're going to use the same points, -2, -1, 0, 1, and 2. So we have -1/4 times 0 squared. Well, 0 squared is just 0. 0 times a fourth is still 0. If I instead then plug in a 1, order of operations, remember, do our exponent first before multiplication and division. 1 squared is 1. 1 times -1/4 is still -1/4. If you want to write it as a decimal, -0.25, you may as well. And then plug in a 2. 2 squared is 4, so we have -1/4 times 4. Well, a fourth 4 times, or you can just plug this in your calculator. If you have a fourth of $1, 25 cents, 4 times you have $1, but it's negative, so just be a -1. If we plug in our numbers on the other side, we'll get the same answers. If I start by plugging in a -1, -1 times -1 is just 1. 1 times -1/4 is still -1/4, or -0.25. Same thing with a -2. -2 times -2 is positive 4. 4 times a fourth is 1, but it's negative. So I'm going to plot these points. 0, 0. At 1, we're down 1/4. At 2, we're down -1. Same on the other side, a fourth, and then -1. So make a nice curve here. Don't just draw a straight line. I don't want just that. That's a linear function. We don't have linear functions right now. We have quadratic functions or parabolas. So let's compare these graphs now. We did a vertical shrink, meaning our graph got wider. It also flipped over. It's on the bottom side of our x-axis now. So first, we did a vertical shrink by a factor of 1/4. We multiplied everything by a fourth. They got closer to the x-axis. And then we also did what's called a reflection, meaning our graph is flipped under the x-axis now. It's flipped over the other side. Then we have our axis of symmetry. Where does our graph fold in half? This one folds in half when x is at 0. We know this graph now, it's the red one, opens down. I know it opens down also because a out front is a negative. That means it's going to flip upside down. And then our vertex. This one of our new graph, not the parent function, this red one, is the highest point, so that's what we're calling a maximum, and it is at the point 0, 0. So a couple of things, I believe this is a question on your homework today. When does a parabola open up, and when does a parabola open down? Well, we just said this is a reflection because a is negative, meaning it opens down when a is negative. That means it's going to open up when a is positive. All right. Our next graph looks a little bit different. In the past, we just had y equals ax squared. Now we have y equals ax squared plus c. We just don't have a number for a this time. We're going to look at how is this going to change our graph if we just add a number. So it says, again, we're going to compare with y equals x squared. So I'm going to graph that right away. If I plug in a 0, 0 squared is 0. If I plug in a 1, 1 squared is 1. If I plug in a 2, 2 squared is 4. So there's my parent function. This is what I'm going to compare to. And now let's plug in our numbers into our table for this new function. So again, order of operations, we're going to do our exponent first, multiply and divide, and then add and subtract. So first, 0 squared is just 0, so 0 plus 5 is 5. Then I'm going to plug in a 1. 1 squared is 1. 1 plus 5 is 6. Same thing on the other side, because if I plug in a negative 1 squared is really negative 1 times negative 1, which makes a positive 1. And 1 plus 5 is also 6. If I plug in a 2, 2 squared is 4. 4 plus 5 is 9. And same thing, if I was to plug in a negative 2, it would be negative 2 times negative 2, which is a positive 4. 4 plus 5 is also 9. So let's graph this. At 0, we're up 1, 2, 3, 4, 5. At 1, we're up 6. And at 2, we're up 9. And if you want to reflect it over to the other side, you can. If you want to plot the points, you'll get the same answer. So this is x squared plus 5. Now if you look at these graphs, they look pretty similar. The only difference is this graph is moved straight up. This point's moved exactly 5 points up. This point has moved exactly 5 points up, exactly 5 points up, exactly 5 points up. So you can predict what's going to happen with that number there. The plus 5 means it moved up 5. So it says vertical shrink or vertical stretch. Neither one happened. We just call this a translation, or we moved up 5 units. Our axis of symmetry stayed the same. This graph is still symmetrical when x is at 0. This graph still opens up, and our vertex is different now. It is a minimum, it's the lowest point of this red graph, but it's not 0, 0 anymore. Our vertex is 0 up 1, 2, 3, 4, 5. And you can see that from the graph or the table as well. We're going to do one more like this. Now this is going to be more like what your homework looks like, because I'm not going to provide you the table and all of these words. You're going to have to write the words down yourself. There are 1, 2, 3, 4 things we always compare. Stretch or shrink, axis of symmetry, which way our graph opens, and our vertex. So I'm going to make my XY table on this one. And before I graph that function, I'm going to graph my parent function, plugging in 0, 0, 1, 1, and 2, 4. There's my parent function, x squared. And now we're going to plug in our numbers -2, -1, 0, 1, and 2 into this equation. So it says -5 and then x squared, so I'm going to plug in a 0 first, and then plus 1. This is where it's crucial to follow our order of operations. We have to do exponent first, then multiply, then add. So we'll do exponent, 0 squared is 0, then multiply, -5 times 0 is 0, and 0 plus 1 is 1. Let's try the same thing again, but with a 1. 1 squared, exponent first, is 1. 1 multiplied next, 1 times -5 is -5, and -5 finally adding plus 1 is -4. If we had a -1, we still get 1 times -5 is -5, so same answer on the other side. And then last, we're going to plug in a -2. -2 squared is 4. 4 times -5 is -20, and then adding 1, we have -19. Now, you could go by 2's or 3's or something. I'm just not going to graph the -19. We'll just plot our other points that we have. So let's graph 0 up 1. At 1, we're down 4, and at -1, we're also down 4. So you can see this graph got really skinny and it flipped upside down. So those are some of the things we have to talk about. There are 4 things we need to talk about. I'm going to start with the easiest one. Which way does this graph open? This one opens down. Then is this a stretch or a shrink? Remember, a stretch is when a is greater than 1, or absolute value of a is greater than 1. This a is -5, so absolute value of -5 is just 5, or the number 5 is greater than 1. So this is a stretch by a factor of 5. It would have been a shrink if a is less than 1, meaning it's like a half, or 2/3, or 4/5, or some number that is less than 1. It would make a wider graph. But this one's tall and skinny. Think of it as stretching up or stretching down. Then we have to say, what is our axis of symmetry? This graph is symmetrical when x is at 0, right in the middle. And then last, our vertex. The vertex of this graph is the highest point, that's a maximum, and it is at the point 0 up 1. From the middle, 0 up 1. Now, here are a couple that we are going to compare without actually graphing it. Comparing to y equals x squared. So a couple things, we're going to say, which way does this open? I'm not going to do all of the parts here. This graph opens, a is negative, so I know it's going to open down, or our graph's going to look something like this. Then you need to decide, is it a stretch or a shrink? If it's greater than 1, it's a stretch. If it's less than 1, it's a shrink. So this one is greater than 1, so it's a stretch by a factor of 4. The negative tells us that this is also a reflection, meaning it opens down. Those kind of go together. And then our vertex. This graph did not move up or down. There's nothing added or subtracted to the end. So our vertex is the point 0, 0. If you'd like to list your axis of symmetry, you can. But on all of these, our axis of symmetry is going to be when x is 0. We'll get to moving that next time. So in this next one, this graph is going to open up because a is a positive. Remember, this is just y equals ax squared. Is this a stretch or a shrink? Well, a is less than 1, so this is going to be a shrink by a factor of 1/3, meaning our graph is going to be shorter and wider. And then our vertex. Our vertex, we did not have anything added or subtracted for C. So our vertex is still in the middle, 0, 0. Next, this graph, which way does it open? There's no number in front of x squared, so I can assume it's a 1. So I know this is going to open up. It's a positive number. If it's 1, that's not less than or greater than 1. It is 1. So this didn't stretch or shrink. No stretch or shrink. It just moved our vertex. Our vertex is not 0, 0 anymore. It is 0 up 2. We took our graph and we moved it up 2. So it's going to look something like that. I would like you to pause the video and try these 3 on your own. See if you can tell me which way does the graph open. Is it a stretch or a shrink? And what is the vertex? And then click play and we'll check to see if we got these right. So first, this graph A is positive, so this graph is going to open up. This one is a stretch, because we have a number that's greater than 1. It's a stretch by a factor of 2. And our vertex is not 0, 0 anymore. It is moved down 12. So our vertex is 0, down 12. If we wanted to, we could say whether our vertex was a max or a min. Because our graph is opening up, that would be, our vertex would be the lowest point or the minimum point on the graph. Next, which way does this graph open? A is positive. We have ax squared plus c. A is a positive, so it opens up. This one, A is 3/4, which is less than 1, which means it's going to be a shrink by a factor of 3/4. And then our vertex, it is the point 0 down 2. C tells us our vertex right now. If we wanted to, we know this graph opens up, so our vertex is going to be the lowest point or a minimum. Alright, last one. This graph, A is a negative, it's really a -1, so it opens down. Right away, because I know this graph is opening down, I know that my vertex down here is going to be a maximum, because that's going to be the highest point on the graph. This A is 1, so it's not a stretch or shrink. The vertex is just moved up 5. We did one just like this on our notes. 0, up 5. Alright, last question here. This one is just thinking, now that we know that c, ax squared plus c, moves our graph up and down on the y-axis, how would the graph of y equals x squared plus 6 be affected or changed if the function were changed to y equals x squared plus 2? So we were at 6, our vertex was there, but now we're down here at 2. What happened to our graph? Did the graph shift up 2? No. Did the graph shift up 4? Well, they're saying it was here and we moved down. So we're not moving up. The graph would shift 4 units down. That looks like a good answer because we're going this way. From 6 to 2 we went down. Or 4 units to the left. No, we're not going left and right. So our answer has to be C. Alright. Your homework is out of the book, so make sure you get this all written down. Make sure you put your name on the assignment. The first couple are fill in the blank or multiple choice, and then you do have to graph some. Reminder, if it says the word compare, these are the things I want you to compare. I want you to tell me which way does the graph open. Is it a stretch or a shrink? What is the axis of symmetry? And last, what is the vertex? As a point, and is it a max or a minimum? Good luck! Let me know if you have any questions.